Hi, Hat. Here's problem 73. We have a block in the inclined plane, uh, and it's pitched at 60 degrees above the horizontal with a coefficient of kinetic friction of 0.2. So, labeling this diagram is really important in as far as the direction of both the gravitational force parallel to the plane and the friction force, which is also parallel to the plane. Now, for part A and B, the block is sliding down the plane, and it's asking for the magnitude and direction of the acceleration. So, applying Newton's third law, action-reaction pairs, or just forces labeling the diagram, I'm going to first show the component of gravity acting down the inclined plane, and then I'm going to show the friction force acting up the plane. Okay? So those are the two forces along the line of action. F of G, and here's F of F. All right, we're going to add up all the forces along the line of action, which there are two, okay? Which are two, and set it to the mass of the block times the acceleration of the block. All right, so notice in my diagram, I'm showing both those forces. This help you understand where I'm coming from in terms of labeling this diagram. Now, notice that I show an initial velocity vector that suggests it's sliding down the inclined plane at first. So sum of the forces equal ma. Okay. We've got okay. So we have the gravitational force and the friction force. Gravitational force is negative, friction force is positive. Now, in some instances, I would put a negative sign because it indicates the direction of the acceleration. But in this case, we're going to be substituting values in, and we're going to let the left-hand side dictate what's negative and positive. So substituting mg sine theta for the parallel component of gravity with respect to the plane, and mu sub k mg cosine theta equal ma. Notice that the masses cancel. That's convenient. So if the problem doesn't suggest the mass or state the mass, don't worry about it. It's going to cancel. All right, plugging the values in. Sure enough, you get a negative 7.5 meters per second squared. That means it's speeding up going down the plane, the way I have this laid out in terms of the convention. So it's speeding up going down the plane. Now, let's look at part C and D. And part C and D, the block is going to be initially going up the plane. So notice that I have the velocity vector indicating the block's going up the plane. Well, that means that the friction force is now directed down the plane. Because remember, friction always acts opposite the motion. So sum of the forces along the line of action are equal to ma. So we have negative mg sine theta minus mu k mg cosine theta is equal to ma. Sure enough, okay, the masses cancel again. And I'm going to assume that we're just going to add these two quantities together to get the acceleration. So negative 9.47 meters per second squared. So it's slowing down going up the plane. That negative sign indicates it's a deceleration, but the way I have it drawn, the way they're asking us to determine the acceleration, magnitude, and direction, the block is moving up the plane initially. Okay, so its magnitude acceleration is greater, slowing down at a greater rate going up the plane as opposed to speeding up going down the plane. Okay, all right. So there's the explanation. I hope that helped.